I got, those videos. If you haven't watched them, watch them tonight, right? Reinforce this stuff. Today, I want to review or continue on with Introduction to Momentum. We're going to learn one new aspect to momentum. It's called impulse. Has anybody ever heard of that in a physics-science relationship? Or I'd be surprised if you guys did. Yeah, a general word we know impulse, but we're going to talk about what the scientific definition of what an impulse is. We're going to add that to what we've been talking about with momentum, right? So I'm going to finish up kind of those intro slides, and then I have some. Your homework assignment tonight is doing some, this 5.1 momentum and now impulse. We're going to, through AP, I have some problems that I want you guys to do. I am going to let that be like today I want to give you work time, and you can work with other people, right? Now, that does not mean, Brody does the work and Andre copies it. You guys can work together and dialogue, like, I think it's this way. No, wait, I think it's this way, and here's why. No, you forgot this. Work together to help each other. Don't copy each other. You're going to be shooting yourself in the foot. So if you copy something down, you don't know it. Then when you go to take the test, you're not going to know it. And when you take the AP test, you're really not going to know it. So really, I want you guys to work together, but in a collaborative sense. Help each other out, right? Fix each other's mistakes. Like, wait, you forgot to consider this. Oh, yeah. You learn by doing that, right? So I want that time to be, you can work on it by yourself, of course, but, check in with people like, hey, do you know how to do this first question? I'm close, but not quite. So that's going to be what I want to do at the very end of class is I'm going to give you guys time to start your homework. And then I'm going to try and meet with each of you one-on-one. Remember I had mentioned I need to check in with you and see, like, hey, what other AP classes are you doing? What other extracurriculars do you got? I need to kind of get a sense of kind of how busy you are, what's going on outside of just physics class. Some of you I see in another class, but most of you, I only see you in these 90 minutes. I want to know kind of what else is going on in your lives so that I can have a better sense of your situation, how busy you are, if, there's things that I need to be thinking about, like, oh, crap, these guys are really busy. I need to, post more things on here that they can do at any time, stuff like that. It's not a big deal, but I just need to get that done, and I want to do that today. So I'll turn you guys loose at the end to work on your homework, and then one by one, I'm just going to meet with you. It'll take like 2 minutes, right? So that's the gist of what I'm wanting to do today. The other thing, I want to do a review session. Remember, like I was talking about, like the once a week. You guys had said after school would be better than obviously in the morning. That'd be terrible.
No, that's not that bad.
And well,
Josh, shut up.
most of you guys struggle to.
2 AP classes, what's the third?
What? Wait, what do you mean? What'd you say?
You said like a morning session?
Yeah.
I said I already have to do that for 2 other AP classes. So what's the third?
You have morning sessions?
Yeah. With AP World and Cal.
At what time?
6:50 to 7:20
Dang.
for World, or 7 to 7:30
Wow.
for Cal.
That's crazy. But I wanted to ask you guys, is it going to be better to do that Thursday or Friday? 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 Okay, that works better for me, so that's good. I was kind of hoping
In that case,
Yeah, study. So again, I want that to be right after school, right? So if they're not mandatory, that these are extra, these are up to you, right? I encourage you all to come because you can ask me questions like this homework assignment, right? If you don't finish it, you get stuck, nobody can figure it out. That's a great time to come in like, Mr. H, no one can get this question. Can you help us? Absolutely. Any questions in general if you want to review stuff. And then again, Maggie had what AP Calc you have that? The freaks. I think that's a good idea to start practicing free response questions. So we can all take some time to do a free response question. There will be those on the AP test. They're trickier, right? They're open-ended. They're multiple parts from the same question. they're less clear cut than a true false. So I want us to start practicing and getting exposure to how AP is going to word those and phrase them, how to kind of navigate answering those questions. That's at least the planned aspect that I'm going to have ready. So we'll do that Friday. Again, any and all of you that can make it and want to, please show up. I'm going to try and keep it short, right? I definitely don't want to go over an hour. If nobody has questions and we're all kind of good to go and I don't have anything I really want to nail down, we'll do an FRQ, practice that. Could be done in 20, 30 minutes, right? 45 minutes is like my max cutoff. At that point, I'm going to be like, hey, let's save it for later, get you guys home for your weekend. I will want to go home and start my weekend.
We can just follow you home and we can just continue to stash at your house.
Ironically, my wife would actually really like that. Because she's at IWU. So she's done. Their semester is over with. So right now she has like 6 weeks of her winter break.
Is she an introvert or an extrovert?
Extrovert. And so she's bored out of her mind.
Okay, I got an idea. I'll just hang out at your house all day.
Just come.
Then she can come here and she can do all my stuff.
Do your schoolwork?
And then she can hang out with you.
Did you say physics Christmas party?
Yeah.
Physics
Christmas.
Yeah, exactly.
Physics and Christmas.
That would be cool.
Yeah, see, wouldn't that be great? This is you guys' first Merry Christmas, and you get to hang out.
You're gonna hang out with the high schoolers.
That's all I wanted to do was go back to high school.
See, there you go. I don't know what we make the tree out of, but it have to be something
It has to be something physics related. I guess trees.
Yeah, I'm not sure.
Are science and science.
Anyway, that's the plan for that study session. I want it to be quick, but I want to make it. I don't even want to know. I want to make that study session worth your time, right? So I'm going to try and keep it short, keep it concise. Got questions? I'm here. We can review some stuff quick, do a freak, right? Get that extra practice, extra exposure, especially now to slowly build up preparation for our AP test. All right. Also, general trajectory for this semester. December 18th for all of your classes. December 18th is the last day of school for semester 1. We're going to go on break after that. December 18th is when all of your grades are due. Whatever your grade is December 18th, that's what it is. So if you guys have poor grades, now is when you need to start figuring that out. If you got missing work, now is when you need to start turning it in. All right? Not only this class, but all of your classes. My kids were unaware that the break was coming up so soon. I was like, how is this a surprise? Everyone should know this. So that's coming up. Unit 5 in this class, momentum. We're on schedule to end that unit 2 classes before break. So we'll take that test if things go the way they should, which we're on track. It'd be like the Wednesday before break. And then we would have Friday, we'd have class. I'm not going to start the next unit. We can have half of a, let's think about how to plan for the AP test, like long-term planning. We can talk about that, work through any questions you guys got. And then the other half of class, I want it to be really casual, more or less mini Christmas holiday celebration. Right? That's my general trajectory for kind of how the rest of the semester will look. Okay? Right? This unit isn't too long. It's pretty straightforward. And we're on a good pace. We're off to a good start. I like it. I'm excited. And I hope that we crush the Unit 5 test. So just an overall chit-chat about kind of where we're headed. All right? So today I want to, like I said, finish up the momentum slides. Where did they go?
Yeah.
It's true.
It's all true.
You have a chance.
It's already happening. It's already happening. We're not even going to celebrate Christmas with our own families. We're like, oh, they're going up to Mr. Heinzman's house. Wait, and so
No.
you guys are just going to be chilling by
It's
yourself?
open. See,
Yeah, it's open.
We can make
I know for a fact I'm going to triple check that I locked my house before I leave. I I'm having none of you sneaking in.
Wait, when he's gonna be gone, it's even better.
We can zoom. We can zoom into.
Yeah, all we gotta do is make sure.
We all show up at your house, and you won't be there, but we can just Zoom call you like at 4 a.m. at your house. Guess what?
You guys are.
I think it'd be
Come
great.
on.
You would love it.
There we go. All right. So, guys, I need you to focus up. All right. So, I'm going to quickly review what we've talked about. What is momentum equal to?
Yes.
Mass and velocity. Good.
I do have that actually.
Mass times velocity is momentum. That's it. That's your golden equation, right? Momentum is a vector. It has a magnitude, and it has a direction. And yes, vector on Despicable Me absolutely gets the correct definition of a vector. Magnitude and direction, right? Units. Units are easy. You know the units for mass. It's kilograms. You know the units for velocity, meters per second. Kilograms times meters per second is kilogram meter per second. Those are the units for momentum. Comes straight from your equation. So, if you have no velocity, whatever the mass is times 0 equals 0. No velocity, no momentum. That should make sense mathematically, and it should make sense intuitively. Something doesn't have momentum if it's literally sitting on a table. Also, the mass and velocity can vary and give you the same amount of momentum. I gave this example. Tomahawk missile, 1,000 kilograms, but 100 meters per second. Right? Oh, shoot. Does anybody remember if I was standing over there last class? Was I standing here? Good, because the camera is pointing up here. If I was over here, I'm saying, hey guys, look at this. The people on the recording can't see anything. Okay, thank goodness. That would have been like a 40-minute video wasted. Same thing, a semi-truck could have way more mass, but a much lower velocity. Your momentum, your mass times velocity, it's exactly equal. They have the same momentum, right? Not only does your mass impact the momentum, but your velocity also does, right? That also leads into this example. The crazy matchup. Who has more momentum? Little bullet moving really fast or big turtle moving really slow? Well, we put numbers to it. They were equal. Momentum is mass times velocity. I have to calculate it for both scenarios. I have to consider the mass and the velocity. Turns out they're the same, right? I need you to understand something can be moving incredibly fast and therefore have a lot of momentum. You could also have something that's incredibly massive. Even if it's going slow, it still carries a lot of momentum. You have two variables in the equation. You have to understand that both of them impact the total momentum. So then we said, okay, they have the same momentum. Which one moves the wall more? Right? Really fast but low mass. Really slow but high mass. They had the same momentum. The impact on the wall was the same. It's just this energy, that momentum. This situation, it came mostly from the mass. This situation, it came mostly from the velocity. Right? So, this situation, we're now going to look at a before and an after. At the beginning, we have 1,000 kilograms moving at 30 meters per second. The momentum at that point in time is mass times velocity, 3,000. After, there's something that happens, and we have a scenario number 2. It's the same object. It's increased its velocity. The momentum, you should know automatically that the momentum changed. I don't have the same mass and velocity. I have a different velocity. I've increased the momentum. You had a change in momentum, right? Y'all should remember this delta, this triangle. Delta means change in. We're now going to look at a change in momentum. Before and after something happens. This change in momentum, you take the final momentum minus the initial. That's always the case for a change in. The delta, you always do the final result minus the initial result. So the change, this is not a momentum, it is the change in momentum, was 20,000. Obviously it makes sense. The momentum increased by positive 20,000. You can write the equation like this. Your mass stayed the same. It'd be basically mv final minus mv initial. Well, the mass is the same. I could pull it out. Then I have v final minus v initial. That's just delta v. So you could have calculated it directly and said, oh, my velocity changed by this amount. If I plug that in, my mass was the same. I can calculate the change in momentum directly. Either way that works for you, I would stick with that. If it makes more sense to say momentum initially, momentum finally, subtract the two, great. That's the most straightforward, logical way. If you understand that, okay, mass was the same, only velocity changed, I'll just calculate the change in velocity, plug it into momentum to tell me the change in momentum. Whatever works for you, stick with that, okay? Two ways to do the exact same thing, all about the change in momentum. However, this equation is going to be useful. I'm going to go throwback. Newton's second law, F equals ma. This is just a different way to write it. If I multiplied by m both sides, I got F ma. It's a different way to write it. All this is Newton's second law. However, A, acceleration, by definition, is the change in velocity over the change in time, or the duration of time that change took. What happens if I plug that into Newton's second law? Right? I'm going to take A and replace it with this. So I say instead of F over m equals A, acceleration, I'm going to replace this with the definition, delta V over T. If I rearrange this one more time, I do cross multiplication. I move the m over here and move the t over here. I've just rearranged this equation. This is just algebra. You guys follow this so far?
Mass times the change in velocity equals speed.
No. Force times time. Does this look familiar?
That's what was on the other one, right?
Be very careful. What is this? Brody? The change in momentum. I'm not being picky, but science is picky by definition. M delta V is the change in momentum. What does that mean?
Momentum is just Newton's second law.
Yes, they're related. We've shown that. What is this equal to? We just said it.
Change in momentum.
Change in momentum. We have another equation. We use Newton's second law and the definition of acceleration to get this equation. This is defined as the change in momentum. So we have an additional equation. Instead of change in momentum equals m delta v, we have change in momentum equals F times t. Right? You all should see that this is just algebra. There's no magic here. It's just using equations and combining them together and seeing relationships. This is impulse. Super important that you get this. Impulse is another key variable in this unit about momentum. The change in momentum is equal to the impulse. The impulse is, by definition, the force applied on an object multiplied by the time it takes for that force to be applied. If I apply 5 newtons for 2 seconds. What's the value of my impulse? 5 and 2. What is the impulse equal to? 10. What are the units? We got Newton seconds, right? No. Newtons times seconds. However, Newton, what's the base units for a Newton? You guys remember this? Check back up here. Right? Force equals mass times acceleration. What's the units for mass? Kilograms. What's the unit for acceleration? So that means a Newton has to be a kilogram meter per second squared. That's what a force is. What if I take kilogram meter per second squared and multiply it by time, which is measured in seconds?
It becomes kilogram. Oh, okay.
Kilogram meter per second, which is the units for momentum. So you can use units to confirm that this is a true relationship, because the units are correct. So, big thing, impulse is equal to the force applied on an object multiplied by the time that force is applied.
So that's the impulse.
Yes, this Ft is the impulse. And the impulse is equal to the change in momentum. That means if you apply an impulse to an object, you will change the momentum of that object. Right? That's the big thing that we're connecting with this idea of momentum and this thing called impulse. Impulse is what changes the momentum. Right? Same way that a force is what changes the velocity, impulse is the cause. Momentum, or a change in momentum, is the effect. These two are directly tied. J, a capital J, this is the unit, the variable name that we give to impulse. It's not an I, it's a J. Please don't ask me why it is that way. I would have to look up some scientific history research.
Don't ask me.
Yeah, please don't.
Probably something to do with like the Greek letter or something.
Don't. I'm not sure why, but capital J is the variable for impulse. It's equal to the force times the time.
Because lowercase j is already joules, right?
Well, capital J is joules, but that's a unit. Like your answer is, 10J. This is in an equation, right? J equals Ft. So these are variables, not units. It's a good point to make that difference. Now we have a new equation. Instead of change in momentum equals m delta v, we have another equation. The change in momentum equals force delta t. If you want to know how the momentum changes on an object, you need to know the average force applied on that object, and you need to know how long that force was applied. If you know those two things, you can calculate how much the momentum of that object changed. So change in momentum and impulse are directly linked together. The impulse is the cause, a change in momentum is the effect. Any questions about that? Okay, pretty straightforward so far, right? So, you have an impulse, a force times a time that had a value of 250 Newton seconds. Force times time. Those are correct units. They're not simplified, but that's okay. It caused a change in momentum of 250 kilogram meter per second.
That makes sense because they're equivalent to each other, so they
Yeah.
do the same number, just different.
Yeah, the units are actually the same. It's just you simplify this to this. You're exactly right, John. These are equivalent. No duh that they're the same value, because we know that the impulse equals the change in momentum. I'm going to repeat myself. It's the change in the momentum. Don't let that subtle thing, mess you up. Change in. Again, these units are exactly the same. I showed you over here Newton second. Right here I did Newton times second, kilogram meter per second, which is the definition of, or the units of momentum. All right? Good. Now I want you to stop and think. Is there multiple ways to have the exact same impulse? The answer is yes. Give me the easiest, or an example. How could you possibly create an impulse of 100 Newton seconds? Remember, what is the definition of an impulse? Force times a time. So give me a force and give me a time that multiply out to 100.
Oh.
Huh? 20 and 5. Say 20 newtons applied for 5 seconds. 20 times 5, that's 100 Newton seconds. That's an impulse of 100 Newton seconds. Give me another example of the same exact impulse. Bingo! You could do the same effect differently. You could apply a higher force for a shorter amount of time and get the exact same result. What's another one?
You could do 1 Newton force for 100 seconds?
There you go. You could apply a teeny force for a very long time. 1 Newton for 100 seconds, exactly the same result. Right? So there's a oops. These are all exactly the same. Right? You're changing 2 variables, but the result is the same. If you do these 3 or 5 scenarios on the exact same object, they're all going to end up with exactly the same momentum, assuming they started with the same momentum. Because remember, impulse is the change in the momentum. All right? It's important to see same thing. Same thing as momentum. You could have a huge mass and a little volume, or the opposite. This scenario, you could have a huge force over a very short time and have this effect, or you could take a teeny force for a very long time. The result is exactly the same because you have 2 variables. What do you think? What is the significance of the area of this graph? If you can't see this, this is force in newtons and time in seconds.
Everything underneath of it
Is impulse. How did you know that, Ethan?
because impulse is force times time, and so
And the area of this graph is force times time. So that's exactly right. Right? You guys should be able to see, oh, force times time. That rings a bell. That's impulse. Literally the definition. So this is another thing to be aware of because AP will likely, they'll want to know, like, hey, this impulse happens. What's the change of momentum? They're not going to tell you the impulse. They're going to give you this. Right? They're actually going to give you just this. They're going to say, hey, what's the change of momentum? And you're going to be like, wait, you didn't tell me the impulse. I can't figure that out. You can. Right? They're going to make you understand force times time is what an impulse is. You just find the area of that curve. That's what your impulse is, and then you can do the problem. Right? That's what they make those extra steps to force an evaluation of your conceptual understanding. Anyone can take variables and plug them into an equation. It takes a lot to understand what variable you can get from that data and then do a calculation. So, the impulse is the area beneath a force time graph. Something you should know, it makes sense. Force times time is impulse. So it makes sense that the area, which is force times time, is impulse. Same thing. You got a triangle. I don't care. You can still find the area under that curve. 1/2 base times height. Same thing. That area under that curve is the impulse. I want you to notice its average force. When you calculate it, you don't take the force at one instant. You notice that it's different. You could calculate the area or acknowledge, hey, this area is the same thing as if we cut it right down the middle and did that average force over that whole time. Sometimes they're going to trick you and say, oh, a force of blah, blah, blah newtons was applied for 20 seconds, or on average. That's fine. You can take that average force for the duration of time, and it still gives you that impulse. Last one, I don't know if you'll have to do this. This gets into, like, if we're in calc base, they would give you a curve. You would have to do, what's the area under the curve? How do you find that in calculus?
We're doing inverse derivatives right now.
Like antiderivatives?
Sure.
Integrals?
You have to know what's going
No.
on.
I don't know what's going on.
I'm not in calculus yet.
And that's okay. For those of you that were,
We haven't.
have you done integrals?
No.
I don't know that.
Dang it. But you've done derivatives?
But yeah, we're
All the
doing
time.
like inverse derivatives. Like
Do they call them antiderivatives?
Never heard of the word.
Because antiderivative and integral are the same thing. I don't know exactly what you guys mean by inverse.
so like
It
you
might
know,
be integrals.
He said like you'll have the answer and then you have to like work backwards.
No, that's what we're doing next semester.
Oh, okay, that's what I thought you were saying. That what we're doing.
So instead of bringing the exponent down and reducing, have you gone the other way? Where you add 1 to the exponent and then
No.
put it on the bottom?
No.
Dang it. Okay.
He said we're doing that next semester.
Okay.
We were talking
Yeah.
about.
Yes, integrals is what I'm talking about.
Okay.
In integral, I'll give you a sneak peek. When you guys calculate an integral in calculus, what you're finding is the area under the curve
That's good.
for any function. You find an integral and then you evaluate it from here to here. So you could literally take any part of the graph, calculate the integral, plug in 2 numbers, and get the area under the curve. However goofy this looks, because you use the mathematical equation and do it by math.
That's
Not by geometry, it's not that hard. It takes a while to learn how to do that.
This is not okay.
I'm telling you, you probably won't do this at all. Again, this is an algebra-based class. But I want you to understand the concept is exactly the same. Imagine you have this goofy changing force over a certain amount of time. You could still find the impulse. All you need to do is add up the total area, under that curve. Now, I'm telling you, you won't have to do that because, again, this is an algebra-based course.
Good. Because calculus is easy fun, friends.
So the first part of the graph, 4 seconds, 40 newtons, but it's a triangle. So 1/2 base times height gives you 80. Right? 40 times 4 is 160. Divided by 2, you get 80. However, the graph continues. What do you do with this area? Subtract it. This is below the x-axis. This is negative area. So I got to calculate the area under that curve. It's 20. And I got to add positive 20 and positive 80, negative 20. And the total impulse from start to finish is 60 newton seconds. Now the question would be, okay, you found the impulse. I'm telling you the change in the velocity was 30 meters per second. You're supposed to tell me how massive was that object. How do you do that? Look through your equations. Your variables are impulse, which you've already found graphically. Your other variable is change in velocity,
Yeah, so you just
delta
plug it
V,
in.
and then M.
Yeah, so delta V and M are on the same side, and then impulse is on the other side. And so you just bring the 30 over, or you multiply
Yeah.
30, so it's what?
Remember,
A mass of 2 kilograms? Yeah. So the mass
Remember
of
this
2 kilograms
equation?
on the same side.
what's Ft?
Impulse.
Impulse. That's equal to M delta V.
And we
That's the
have-
equation we want.
Yeah.
We found impulse from the graph.
they give
It
us
told us
delta
this and asked us for
V.
mass.
So just divide. And what do we-
Come on, keep up with me.
30 and say it's 2.
Bingo. Right? You know that the change in momentum is equal to the impulse. So I put 60. Impulse is equal to mass delta V. They told you delta V From there, it's a plug and chug. That's why physics, sure, this is simple algebra. Hardly any high school student, or almost any high school student could do this. But this is physics. You have to understand, how did you get this number? Well, it's area under the curve. I know that. And then I know the impulse is the change in momentum. And I know one of my equations for change in momentum is mass delta V. It's how it's, sure, it's just algebra. You can plug that in, but you got to know how to get there. That's an example of how AP, they're not going to test you on your algebra skills. They're going to test you on your physics skills. You use your algebra skills to get where you want. All right? So in this situation, they did a lab, and they measured the velocity over a certain amount of time, and they found the change in velocity from start to finish. During that same time, they calculated the average force, right? So from those numbers, right, they mathematically measured stuff. They found that here's your delta V. You know the mass of the cart. Area under the curve for a force time graph. That's your impulse, right? They calculated that, and they know the impulse, they know the mass, and they know the delta V. So you can experimentally determine or measure the impulse. These two things should be equal. Mass delta V should equal impulse. Yeah, see what it comes out to. So again, mass delta V.
0.96876.
Pretty close. So it shows you kind of the what was it, 0.96?
0.9687.
Okay, so it's pretty close. You're like a tenth of a kilogram or Newton second off. That's pretty good.
100.
What?
100.
100. Thank you, yes. So you can experimentally see how close how accurate your measurements were. Okay? Think carefully about this. This is where it's these deep thought questions are going to come in. It might sound easy, but they're going to ask you in a weird way. Which object would have a larger change in momentum if this guy, the same guy, pushed for 3 seconds on both vehicles? Take a second, don't say anything. Think about that. The question is asking you which one has a larger change in momentum. Assume both vehicles start from rest. The same guy pushes for the same amount of time. Got to think about, how do I figure out the change in impulse? What is that equal to? And how do I think about what's happening to tell me which scenario produces a greater, less than, or equal to change in momentum? Aiden, you got a thought? Okay. Josh, what do you think?
This, I don't know why, but I feel like neither.
Okay, so you're saying neither?
I think like they're equal.
Equal? John?
I don't know why,
I think it's neither because
Yeah, give me why. Good.
I think because it's the same guy pushing on them, and so wait
Okay, that's good. Yeah.
a minute.
So
What
you're
variable is he when he's
So
pushing?
he's
What,
using the same force, and
Yep.
it's the same
Yeah.
amount of time for each.
so if I got the same force and the same time,
If the momentum changes.
what is that? Force times time. Impulse. If they both, you just said they have the same impulse.
One of them has a larger mass.
Okay, that's true.
They still have the same momentum because it'll be the same force.
This is where you got to time
No, no,
out.
change-
What was the question asking?
The change in momentum.
The change in momentum.
there wouldn't be.
Which is impulse.
That is impulse. Maggie said change in momentum is impulse. If they both had the same impulse, they had the same force, same time,
Okay.
what does that mean about their changes in momentum?
It's the same.
They're the same.
Okay.
Good. I wanted to walk that through because, again, some of you might have read it like, oh, this one has more. Well, no. The question wasn't who has more momentum or who had more mass. It was which one had a greater change in momentum. You got to pause and say, okay, what is the change in momentum? Maggie said it's equal to the impulse. What is an impulse? It's a force over a time. What forces are applied? Oh, well, it's the same guy. What time duration for both? It's the same. Oh, same force, same time, same impulse, same change in momentum. Right? So I want you to, when you're taking any tests in general, but especially the AP test, don't go so slow, but be careful when you read a question. Don't fly through a question. Read it. Figure out what it's asking. A lot of you guys might make really, really simple mistakes because you didn't bother to figure out what is it actually asking you. They're going to be really subtle with their questioning and their wording. All right, same scenario. Or at least very similar. Which object would have a larger change in momentum at the finish line? This is a good question. Same guy, so same force. What it's asking you is once the vehicle gets to the finish line, which object would have a greater change in momentum? This is a tricky one.
Neither, they both crashed.
Right.
Come on.
Happy helicopter one, and a lot of boys not.
Larger change in momentum. What I want is delta P. What is delta P equal to? There's two answers you could give.
Change momentum.
Huh?
Change momentum or
Impulse. Yep.
It'd be the no, it'd be-
Impulse is, oh wait,
It'd be the car, wouldn't it?
F delta T. Impulse is also equal to, or excuse me, change in momentum is also equal to M delta V. So there's two ways you could think about it. Well, we know the force is the same for both of them.
Yeah.
That guy is pushing the same amount at any moment in time for both objects. So the force doesn't help us answer the question at all, because it's the same for both. What about the time?
the change in time
The
since
car has a higher time to get there
Why?
because it's
It has
more
more-
massive and harder.
There's more mass. Not only can you think about Newton's second law, F equals ma, if you got a constant force, the motorcycle will accelerate more because there's less mass. So that's important. What does that affect?
It means that
What variables?
the change in time.
It affects the time from start line to finish line.
Doesn't it also change the velocity? Because the car is going to be moving slower than the motorcycle.
Yeah. Right? If I push the car, it might start moving at 1 meter per second. It'll go, and then eventually it'll get up to 2 meters per second. Right. Oh, excuse me. But the whole time, it's moving. It's getting closer. It just changes its velocity slower. The motorcycle, it starts picking up speed really quick. Right? So, how do we figure this out? One way that you can solve these is, if there's no variables given, just make some up, right? Let's say that the force, let's do car, motorcycle. Right? Let's do this, Ft. Assume the force is 1. It really doesn't matter, because the force is the same.
Looks like a working man. It's probably not very strong.
What?
Looks like a working man. It's probably not very strong.
Delta T. We can't really evaluate that. Or can we?
Well, we know that the motorcycle will take less time.
True.
But we don't know how much.
Right. But could we answer the question?
I mean, if we just put any number in there.
Because it's specifically the change in momentum at the finish line. Let's try another one. This equation is also equal to the mass. What mass do you want for the car? Something simple.
5.
What?
8.
Can I do like
I said 5.
10 or something?
10.
Negative
I
8.
want to make our math easy.
4.5.
10 times a delta v.
Take
It
it
would
away.
like tap it or
Let's
something.
do 2.
Alright.
Right? Sure. So if we have these two equations, okay, we have two separate equations. One for the car, one for the motorcycle.
10,
What times 10?
Do you
10.
see a way that these can be compared to each other? Right? The car has 10 times delta V equals 1 times delta T. 1 times delta T is the same value for the motorcycle,
So you can say,
which is 2 times delta V.
so you can just get rid of the middle.
Get rid of the middle, right? Do you guys see what I'm doing?
2 times.
Two equations, if these are exactly equal, say this is x, and this is also x, x equals this, that means these are equal to each other.
Is this a
Well, what does that mean?
Means the
If these are both equal, is the question asking us the which has a greater change in velocity?
Change,
What is it asking us?
change in momentum.
Change in momentum. Isn't this a change in momentum?
Yeah.
If this for the car is equal to this for the motorcycle, how do the changes in momentum compare?
They're
cars
equal
like
to
five
each
times
other.
bigger.
They're the same. The delta
Oh,
V.
that's cool. I'm done. Yeah.
Again, that's what I'm telling you. You gotta be very careful
Yeah.
with what the question's asking.
It's kind of horrible.
It's gonna be tricky, right? Unfortunately, AP for certain questions, they're gonna be out to trick you.
Yeah.
These types of questions that most people are like, oh, I know the answer. Those are the questions that are going to differentiate you from getting a 3 versus a 5. Or sometimes a 1 versus a 3.
I was gonna say a 3 or a 5 at that point.
They make it really challenging so that if you really know your stuff, you're going to get that 5. You're going to earn it. If you know the basics, you're going to get that 3. That's that passing score that you guys all should shoot for.
$100 is $100.
Of course, with $100.
All right?
So the answer is neither.
Yes.
Okay, so I was right originally. I mean, I don't know. I couldn't back
So
it
they
up,
both
but I
crashed.
just seemed like
But what?
They both crashed. That was my guess.
yeah, an A10.
It doesn't
Yeah.
matter. He won't get to the finish line. He's wearing dress shoes. There's no way he's going to be able to get that far.
You get calluses before you get there. So I wanted to, this is a really good question. It's not super intuitive. Some physics problems you can go by intuition. Like, oh, I know, it makes sense. But this one isn't so clear. Right? And the question is something very specific. Right? If the question asks you which vehicle had a greater change in velocity, oh, that's easy. It's the motorcycle. Right? This number has to be huge to equal the same thing over here. Right? So that's what I'm saying. Just be very careful. Take that extra second to thoroughly read the question. Figure out what exactly it's wanting you to find.
He seems like that type of guy to say that it's exercise.
Maybe.
Yeah.
To get
He's
it
actually
crispy
sorry
green.
because I'm pushing his motorcycle around.
Saving gas.
Yeah, exactly.
He's probably out of gas.
That's probably what's pushing.
Okay, I
And
think
he
I'm
just
going
wants
to pause
be
there.
environmental friendly. So he pushes his motorcycle. Map. Motorcycle, so you can push it. And then he hops on it and rides down the hill. He just squeezes the clutch and just goes down.
Yeah, I want to pause there. I want to make sure I give you guys time for the homework. There's more I could go over right now.
That's okay.
I'm going to wait. No, I'm going to do homework, all right? We need to practice this stuff. So, you guys, the rest of this class, what I'm going to do, I'm going to turn you all loose, right? I want you to work on the homework. It's on myAP Classroom. It'll be 5.1, right? You guys can work together if you'd like, right? Don't be sharing answers. Help each other, right? If your partner doesn't understand, help them understand. Otherwise, if you just give them an answer, you're actually not doing much for them, right? But I want you, it's okay to work together, right? Help each other out. Otherwise, work for yourself. I don't care. But I'm going to turn you loose to work on that homework in class right now. And then I'm going to meet with you one-on-one. It'll, again, take a couple minutes each. And I just need to get some more info about you guys. All right? Sound good? My other final reminder, what did we say? Friday? Friday we're going to do that review session. Right? So Friday right after school, just head to my room. Again, it's not mandatory, but I'd like you to show up. Virtual or quarantine students, I will post a notice in Google Classroom. I think our classroom has a unique join code that if you're a quarantined or virtual student, right at 2:30, you can join that Google Meet, that link, and I'll have my computer right here so that you'll be able to listen to us and go through the problems live along with us. All right? Otherwise, if you're available to come, please show up for that review session. We'll make it short and sweet. We'll try to keep focused and get you out of here so you can start your weekend. So again, rest of class, work on that homework. It's on AP Classroom. You can work with a partner, right? If you have questions, let me know. But again, I'm going to be coming around one by one and just meet with you guys quickly, all right? Okay, so I'll turn you loose. I'll stop this. Come on.
Back on before Josh.